world, but it's really tough to quantify the data at the time. So that's what the project is about. We're trying to quantify the data and to price the data and to understand the risk involved if the data is transacted on a platform for which Delhi is helping me with that. And so I'd say there are like four principles which make up good data practice, which is where the data is coming from, and what is the privacy level of the data, and is the data protected? What's the encryption that's been used, and we should know how to refine the data, because unless and until the data is refined, it's of no use. So I would say these are the main principles that have a good data practice. But as I mentioned, there are a few problems with the data. So if the data needs to be transacted, so the problem with data is as with physical tangible goods or services is once it's given, it can't be replicated. But the problem with data is it can be interpreted into multiple ways, and it can be replicated very easily. The other problem, I would say, that it is combinatorial, which means that when the data is combined with two or other different data sets, it can potentially it can create a potential correlation of data, and it gets difficult to set prices according to the correlation. So that is the task. That is the biggest task, I would say, with the current market scenario. And again, so the prediction of data again depends on like multiple various factors. Different people different perceive the data in a different way. Depends on what needs to be done for, what is actually required from the data. uh, and to price data on the basis of prediction task, it's a bit difficult task. So what we have tried to do is we have tried to inculcate accuracy factor, how accurate the data is, rather than how predictable the data can be. And uh, the last thing that I have noted the problem with the data is, so without first applying it to a prediction task, we cannot really know the value of the data, because most of the organizations do have data, but we need to clean it. We need to make it like work for us. So what the prediction models were used, what the regression models are used for the data to be used. So it gets difficult unless and until the data is cleaned, and it predicts something. The data is not useful to anyone. So that is again a task here. So to create a desirable marketplace where a bunch of buyers and sellers will come and sell their data, so there are different tasks. So if we try to value the data based on the accuracy level, so accuracy needs to be a time series function based on like multiple factors again, which can be what kind of percentage change can the data predict. Or if I suppose if an organization says that I need a 1% increase in my revenue in a particular sector, then what kind of accuracy of data does it need, and what kind of prediction or task it can inculcate. And accordingly, that's how a buyer will come to the market, and the sellers will have a data set which is raw, which is anonymous, uh, and it is not predictable. So that's an assumption that needs to be kept into a seller market. That's what we are going with as of now. And the other thing which is a major factor is, I would say, is how to get firms to bid truthfully. So if we start bidding for if the buyers start bidding for the auction, so how the pricing mechanism would work, so and how truthful the co- uh, the auction or bidding prices will be. So even that needs to be monitored, because it can be way too undervalued or way too over valued. So to have a major balance with that, with the truthfulness of the bidding, that's that's what that is again a task. That's how the pricing mechanism will work to get into a proper certain range, I would say. Moving forward, so what we are trying to do here is quantify and compute the whole process, and the way we have noted it down, there are a few points. So first and foremost, identify variables for each risk factor, which we have already done. I'll show it to you in a minute. Moving further, and then moving forward, define how variables will be measured. So because data is again like if we try to quantify it, some of the data is string oriented, like what we can say in a coding pattern. Some are objects and numericals. So it's easier to quantify some things which has a financial value, but it's difficult to quantify something which has a string value. Suppose somebody's name or address also has a value. It's difficult to quantify that just on the basis of name and contact or somebody's age. So I'm trying to standardize the same based on the risk. We are trying to understand based on the risk of what the data will be and what the intent of the user might be. So that's how we are approaching that problem. And then defining variables with define how variables might change with changing circumstances. So bec- and data is dynamic, so because it keeps on changing, that it can be interpreted into multiple ways. So it needs to so a lot of combinatorial functions had to be defined for a particular set of data, that if it is combined with this kind with certain type of different data sets, what kind of changes will it make. So for to define a perfect range of auction or pricing, I would say that that's a major part where this will play a big role. Then to remeasure variables dynamically with changing circumstances, and finally to create an algorithm to model all the above. Moving forward, so we are so Delhi has built so Delhi is Delhi has built a platform where we are trying to container keep the data into containers, which we call it as iCubes, uh, where it is non-transferable. It will be encrypted, and so for example, if somebody wants to open a bank account, new credit card, so these are just a few examples which I've put up here, and these are the different types of data forms which a particular iCube will have. Now, as I was mentioning earlier, that suppose some buyer comes and he wants data for a people to open different bank accounts. What mostly current fintech companies or just trading platforms are trying to do. So I guess this data sets this iCubes will be of a major help there, where we have created a multiple number of iCubes with different data sets and data records which have the particular information of the clients, and also we are trying to set a correlation between different types of cube, that what will happen, and also with different correlation with individual data records as well. So as I mentioned, so we have noted that there are this few risk categories which are involved with each and every data sets, and we are trying to categorize each and every data sets into these categories, which will help us moving forward to categorize and to quantify the risk majorly involved during the transaction. So as I mentioned earlier, like trying to quantify and standardize the process of bidding. So when a seller come to market, so this is what I have been able to come up with the help of multiple research and multiple different papers. This is where one of the paper called as Data Marketplace helped me a lot. So when different sellers and different buyers meet at a particular platform, so to standardize that and how a particular valuation of the buyer will increase with accuracy of the data, that needs to be calculated. So that is what I have defined a few variables, and we are still trying to standardize this particular sets. And then we have tried to calculate the probability and impact of the data. So mostly in the current scenario, the way the data or data organization company is valued, what if the data will be lost moving forward? So keeping that in mind, with the current market scenario, that the data is only valued when the data gets lost. So and we have tried to define data based on these three factors, which is confidentiality, accuracy, and availability. So confidentiality means that what how secret how private is the data to a particular individual, how accurate is the data, where the data comes from, and how the data is, so if it's coming from government issued IDs or from some different source, so that is where the accuracy plays a part, and what is the availability of the data. So and then we have tried to calculate the probability and impact of different data sets. Moving forward, uh, so like as I mentioned about truthfulness about the auction and to set a range for a bidding process. So the major part where this will be so major so the major issue with the range will be like how the allocation mechanism will be done, how the balance will there be a balance, and will there be a symmetry into every transaction about the particular range for a similar kind of data, because as I mentioned, the data can be predicted into multiple ways, and if it is correlated with some other kind of data matrix, it will completely create a different prediction task and prediction estimates. So that is again a task here, but so the major part here is to linearize the data. What we try to do, so basically to regress the data and to linearize the data. So the future, so right now we have been able to create a data to calculate the probability impact and to calculate the risk for a particular the category for the different categories of risk. So for a particular risk, what the individual data point set is try what is the risk involved into a particular data sets for a particular risk, and what if that risk is correlated with different kind of risk. So we have been able to do that. So that is done, and so the future work is to quantify the data, which is to standardize the data, and how the pricing mechanism will work. So for example, Delhi and I discussed that if the buyer is trying to bid for the data, and so to create a standardized balance, what usually happens on a bidding platforms, I would say. So not going with the highest bidder, but with the second bidder, but the bidding will keep getting on higher, but the data will be sold on the price for the second highest bidder. So to create a standardized platform, so there are multiple ways it can be done, but that is the best way to move forward as per the game theory as well, going through multiple research papers. And so to and there should be a mechanism which penalizes the replication of the data, and so that is a future work which can be done, which needs to be done, and to try to compute everything, and to so I'll share one more thing with you, just a second. Saying so these are the different data sets which have been created accordingly the risk. And I'm this is just something I try to do. So these are just as I mentioned, so there are different cubes. So if I and I have so for a particular cube set, so I've just given here two, but we have created multiple cubes. So what a particular cube set has, and accordingly I we have recorded what is the confidentiality, accuracy, and availability of each and every data point. And moving forward, like suppose if I so what this data is trying to do here is, if I need to know the sensitivity risk of a particular data set, which is name and address, so this is the score, the scale what we have come up with is 1 to 6 score, so 6 being the highest, being the lowest. So so we have tried to categorize the risk into that format. So the risk factor which comes up is 4. And then moving forward, if the user or the buyer is trying to get to get into a particular data cube, so for example he asks for a credit card cube, so these are the different risk set involved. There still needs to be a lot of work done, but this is what has been done until now. And yeah, so that's it from my